Welcome, students, to geometry. Today's the first day of geometry, and we're going to start on lesson 1.1, and we're going to start on page 4. Start on page 4. And the first thing we're going to start off with is some new vocabulary, and then we're going to bring in some old vocabulary. So let's start out with the vertex. What is the definition of a vertex? A vertex is a point where two or more line segments, lines, rays meet. So, for example, this would be a vertex right there. Or if we have a graph, the vertex would be this point right here. So that would be your vertex. Now, what does vertex form? Vertex form is an equation that shows us within the equation where the vertex is. So I will show you what the vertex form is, and then we'll explain it throughout the lesson. So vertex form is written like this: A times the absolute value x minus h plus k. So let's define some of these terms. A is the stretch or shrink, and that's the A value right there. H refers to a horizontal shift, and then K references a vertical shift. Okay, so we're going to explain what all of those mean here in a minute. So let's take the parent function of an absolute. So let's take the parent function, f of x equals the absolute value of x. Okay? And so let's make a table for this. We're going to make a table, and then we are actually going to, I have these cool little ones cut out, we're actually going to put it on here. So we'll make a table for this first. If you would like some of these little cutout graphs, I can get you some. You can make a copy, or you can just draw it on. Whatever works for you. So we're going to make a table. And we're going to start off with -1. Let's start off with -2, -1, 0, 1, 2. Let's just do those 5. Okay. So I'm plugging in -2 here. I use a pencil for my work so you can see the difference. So f of x equals the absolute value of -2. So that is f of x equals 2. So f of x equals the absolute value of -1, 1. Don't forget, the absolute value equals the distance from 0. So how far is -1 from 0? Well, it's 1 unit from 0. So the absolute value will always be a positive. So I'm going to go over that right here. I'm going to say, let's cross that out. Absolute value is the distance from 0. The distance from 0. So the absolute value of 2 equals 2. The absolute value of -2 equals 2. Because 2 is 1, 2 units from 0, and -2 is 1, 2 units from 0. They're both 2 units from 0. So the absolute value is always positive. The absolute value of 1 is 1. The absolute value of negative 72 is 72. So the absolute value is always positive. So as we're looking at this parent function, absolute value of negative 1 is 1. Well, the absolute value of 0 is 0. The absolute value of 1 is 1. Absolute value of 2 is 2. So let's go ahead and graph that. I have negative 2, 2. I have negative 1, 1. I have 0, 0. 1, 1. And 2, 2. So this is going to be a little bit complicated with the curve in the book. So there I have my parent function of an absolute value, of an absolute. So f of x equals the absolute value of x. So there's my function right there. Now, the one review we have to do with the vocabulary is going to be domain and range. Domain is how wide. It's all x values. It's all the x values. And the range is how tall, which is all y values. So for this parent function, the domain how wide does this go? Well, shoot, it goes on forever. It goes on forever. So it's all real numbers. It goes from negative infinity to positive infinity. It goes from negative infinity to positive infinity. The domain is all real numbers. Now the range is our y values. It's how tall it is. Well, there's nothing below 0, so our range is y is greater than or equal to 0. And if we wanted to write it like this, we would write 0, infinity. So that's our range. Okay? It's all numbered. Y is greater than or equal to 0. It's all of these numbers. All right. And so there you go, domain and range. So what I'm going to do is I'm going to show you this whole vertex form thing right here. Let's graph another absolute. So y, or f of x, equals the absolute value of x minus 3. So let's see what this one looks like compared to our parent function. Let's see what it looks like compared to our parent function. So I'm going to make an x and a y chart. And I'm going to do the same numbers, negative 2, negative 1, 0, 1, 2. I'm going to do those same numbers. So I'm going to do my work in pen again. So the absolute value of negative 2 minus 3, so that would be 2 minus 3 would be negative 1. The absolute value of negative 1 minus 3, so that would be 1 minus 3, so that would be negative 2. The absolute value of 0 minus 3 is negative 3. The absolute value of 1 minus 3 is negative 2. And the absolute value of 2 minus 3 is negative 1. So let's see what that looks like on our little graph. Our little graph. I didn't put these in beforehand because I wasn't sure how much space my work would take up. So here we have negative 2, negative 1, negative 2, negative 1, negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, negative 1. So Here's what my new function looks like. Bird. Bird. Here's what my new function looks like. Now, where's my vertex? We'll look at that in just a second. But first, let's do our domain. What's our domain? How wide is this? Well, it goes on forever. So we have all real numbers. And our range? Well, it goes from -3 up for infinity. So y is greater than or equal to -3. Again, you could write this as negative infinity, infinity. And you can also write this as, oops, this includes. You can write this as -3 and then infinity. If you'll give me a minute, I have to go grab the phone. Okay. So, sorry about that pause. We just got the domain and the range. And one thing I wanted to point out was the brackets versus the parentheses. A bracket means number is included. Parentheses means number not included. And the reason infinity is not included is because there is no number infinity. You can't include it because it's not a specific number. Okay? All right. So let's take notice of one thing. If you see in our parent function, we have, for this function, our vertex. Our vertex is right here. So our vertex is 0, 0. Now, what do you notice about this vertex? So 0, -3. So for this one, our vertex is 0, -3. Interesting. -3, -3. Well, look at this. Our k value is our vertical shift. So we have a vertical shift down 3. Interesting. Let's start trying to make that connection. Let's do one more. If I have room, I might have to write it a little bit smaller. Let's do this one. F of x equals the absolute value of x plus 2 minus 3. So, what do we think our shift is going to be? So think about, what do you think our vertex is going to be with this? Think about what it might be while I glue this on. And let's graph it out and see what our shift is. Okay. Like these little charts. Alright, so let's do our xy. And we're going to do the same thing. -2, -1, 0, 1, 2. So let's put in a -2. So we have -2 plus 2 minus 3. So that'd be 0 minus 3, so this would be a -3. So -1 plus 2 minus 3. So -1 plus 2, that would be 1. 1 minus 3 is -2. Then we'll do 0 plus 2 minus 3. So +2, -3, so that would be -1. And then we have a 1. 1 plus 2 minus 3. 1 plus 2 is 3. And the absolute value of 3 is 3. 3 minus 3, that beats 0. Then we have 2 plus 2 minus 3. 4 minus 3, that would be 1. So let's plot these. Negative 2, negative 3, negative 2, 1, 2, 3. Negative 1, negative 2, negative 1, negative 2. 0, negative 1, 0, negative 1. 1, 0, 1, 0. 2, 1, 2, 1. Huh. Well, that is quite interesting line. We don't even have it. It doesn't even go up. So you know what? Let's check. Let's plug in a negative 3, because I think at some point we're going to have a vertex, right? So let's do negative 3 and negative 4. So if I got the absolute value of negative 3 plus 2 minus 3. So negative 3 plus 2, that would be negative 1. The absolute value of negative 1 is 1. So 1 minus 2 is 1 minus 3 is negative 2. And then negative 4 plus 2. So negative 4, so that would be negative 2. But it's the absolute value, so it would be a positive 2. 2 minus 3 is negative 1. So let's plot these 2 points. Negative 3, negative 2, negative 3, negative 2, and negative 4, negative 1. Aha! Look at that. So, what is our vertex? Our vertex here is negative 2, negative 3. So our vertex is negative 2, negative 3. Hey, what do you notice? Oh, there's our negative 3. But wait a second. That's the opposite. And it is the opposite. And I'll show you why. If you don't understand it, don't worry. But just remember, your vertex is going to be the opposite x value and this y value. And the reason this is the opposite is because your vertex form function is a negative h value. So a negative h value means it's the opposite of what this one is. So the 2, the opposite of 2 is negative 2. So just remember that when you get, this is going to be, your vertex for this function is going to be negative 2, negative 3. There's your vertex. Now just to finish off, our domain. Our domain is going to be, well, goes off forever both directions, so it's all real numbers. And then our range is going to be 1, 2, 3. Y is greater than or equal to negative 3. So please have all this in your student journal. And now we will go to the homework. I will do 1. There's only 4 in here, so I will do 1, and then you will get to do the rest. What I didn't go over is this stretch or shrink. What that does is that makes this, it either makes it taller or wider, like that. So you have your vertex, here's your normal one. If you go taller, it's going to go like that. And if you go wider, it's going to go like that. So it's almost like the slope. So this 1/2 is actually going to make, this is our original one, 1/2 is going to make it go like this. And what's our vertex for this one? Well, our vertex, I can already tell you, there's no vertical shift and there's no horizontal shift. So our vertex for this one is going to be 0, 0. I already know that. It's going to be 0, 0. But let's fill out the table just to make sure. So if x is negative 4, 1/2 of negative 4 is negative 2. Negative 2, 1/2 of negative 2 is negative 1. 1/2 of 0 is 0. Actually, 1/2 times 0 is 0. 1/2 times 2. 1/2 times 2 is 1. Oh, no. This is the absolute value. This is the absolute value. Oh my gosh, I messed up. I'm sorry. Go back. Negative 4. 1/2, the absolute value of negative 4. That's 1/2 of 4, so it would be 2. 1/2 of the absolute value of -2, this is why it helps to write it out. Absolute value of -2 is 2, so that would be 1. Absolute value of 2, 1/2 the absolute value of 2 is 1. 1/2 the absolute value of 4 is 2. So we'll plot this. So we have -4, 2, -4, 2, -2, 1, 0, 0, 1, 2, 1, and 4, 2. So look at that. Just like we had predicted, we have one that stretches. So if you remember, our original function goes like this. And so because we have the half, it stretched. That's your parent function. The pencil is your parent function. So anyways, it's stretched. So take note of that. And then we still have to describe the domain and range. So the domain, let's go right here. Domain is, well, it's our width. And so the width of this is all real numbers. And our range is 0. It's greater than 0. So y is greater than or equal to 0. So there you go. And since this is in vertex form, I'm just going to note the vertex is 0, 0. Okay, your job is to do 2, 3, and 4. But you also get to go to Desmos and write down functions and their vertexes. Write down the function and their vertexes, and I'll show you what I mean by that. So we go to Desmos. I will give you a link in the module, and so you'll write this down, y equals x. So you'll write down y equals the absolute value of x, and you'll say the vertex. You'll look here and you'll say y equals x. Oh, my vertex is 0, 0. So you're going to write down your vertex is 0, 0. And then you're going to write down the next one. And the next one is y equals the absolute value of x plus 2. Y equals absolute value of x plus 2. And the vertex is, so I'll take that one off, and I'll click x plus 2. And here is the vertex, 0, 1, 2. So the vertex is 0, 2. So you're going to write down, I'm going to have 10 problems in Desmos, and you're going to write down the 10. You're going to write down the problems and the vertex. You can write it on this page if you have room, or you can write it on this page right here if you want to, just right here. 1, 2, you can write it there. Okay? All right, nice work. I'm excited for this semester in geometry.